So now let's continue to talk about another example, related to shell method and washer method. Okay. So the question is, find the volume of the solid, so generated by revolving the regions, bounded by the curves y equals absolute value of x over 4 and the line y equals 2 about x axis. Okay, this is the problem. Find the volume of the solid generated by revolving the regions bounded by this, and then revolved by the x-axis. Okay, again, let's try to draw that. Maybe let's see. First, let's use the shell method. Okay, so let's draw that. The graph of the absolute value of x is like the V shape, okay? And the absolute value of x over 4 is kind of like a more flat, a V shape, something like this, okay? And y equals 2, which could be, I don't know, something here, okay? So this is 2. And, maybe we can draw this longer. And it's very easy to solve that this part is 8, okay? Because you put y to here, and then y times 4 give us the absolute value of x. One is negative 8, this is positive 8, okay? And then you're starting to do the revolving about the x-axis. It turns out that you're going to have a solid, in dimension 2, it's like this, okay? And if we're going to use the shell method, keep in mind, when you use the shell method, the integral you're going to formulate will be respected to the axis that is perpendicular to the revolving axis. In other words, the revolving axis is x-axis, and then our integral will be with respect to the y. In other words, we're going to have something from 0 to 2, something dy, okay, something dy. So that's the first thing, okay? It's very important to know this first. And also, and then the next we want to figure out the volume of the shell. Okay, and this is going to be the basic graph of the shell, okay? Of the shell. And, we know that it's going to be the 2 pi times the radius, and then times the height, and then also times the thickness, which is dy, it's already here. Okay. So the radius of this shell, if I denote this part is x, and then correspondingly, you can see that the radius of the shell, we have to write it in terms of y, which is exactly y here. So this is r, the radius. This is the height. Okay. So the r of y which is exactly y here. Okay, so no problem. And then we want to figure out the height, which is the length of this, actually double, right? Double this part, it gives us the height, because this y equals absolute value of x over 4 actually is symmetric with respect to y. So if I know the length for this, 2 times it, done. Okay. So the height of that shell in terms of y, this part, which is exactly x, and then it also lies on y equals absolute value of 4. So we need to solve x in terms of y for this part, which this is y equals x over 4, right? Because positive. So it turns out x equals 4y. Okay, x equals 4y. So this is 4y. So the height is going to be 2 times 4y. So it's 4y times 2, which is 8y. Okay. Or you can think about it, if you solve this part, it's going to give you y equals negative x over 4, because x is less than 0. So it turns out if you solve x in terms of y, is x equals negative 4y. Okay. And so the height, which is exactly the difference of those two functions, which is 4y minus 4y, which still is 8y. So anyway, when we got the radius, we got the height in terms of y, and then we can formulate our integral, which is 2 pi times the radius y, and then times the height, which is 8y, and then dy. So this integral is super easy to evaluate it. So which is from 0 to 2, 2 pi times 8, which is 16 pi, right? So maybe 16 pi times y squared dy. That is, we can take this 16 pi out, y squared dy. And then so 16 pi times y cubed from 0 to 2. Don't forget the over 3. So maybe I should put a bracket here. So it turns out 16 pi times 2 cubed over 3. So it gives us is, 2 cubed is 8. And then this is 16 pi, so it's 128 pi over 3. Okay, so that's how do we use the shell method to figure this out. Well, what about if we use the washer method? Well, we can definitely do that. So again, let me still draw this quickly. This is still 2, okay, and then we got this is 8, okay, this is 8. Well, very different with the shell method. The washer method, you're gonna formulate a cross section here. Okay, and the shape of that cross section is actually the washer. Okay, the washer. And as you can see that all you need to do is to figure out this little radius and then this larger radius. Okay, so if we denote this is r, little r, if we denote this is capital R, and then it turns out that this problem we can have a lot of ways to think. First of all, guys, since the graph of y equals absolute value of x over 4, it is symmetric with respect to y-axis. When we do this revolving, actually the volume of the right-hand side is exactly same to the volume of the left-hand side. meaning we can only focus on the volume for the right hand side, and then we can multiply by 2. That's going to give us the volume of this revolving solid. Okay, so to do that, we can only focus on from 0 to 8 part. Okay, and then multiply by 2. And in this situation, to use this washer method, you can see by your washer is perpendicular to the x-axis, and then depends on where your location, and then your washer, the areas keep changing. In other words, when we're trying to formulate the integral, our integral will be respect to x in terms of y. Okay, and more importantly, we can write into 2 from 0 to 8 something dx. This 2 is to double it because we only focus on the right hand side from 0 to 8. Okay, so now let's try to figure out the small radius and the bigger radius. Okay, so r of x, small radius, this part is y equals absolute value of x over 4, but in our first quadrant, this line is exactly x over 4. Okay, so this little radius here, which is exactly the y coordinate when x is x, meaning it's x over 4. Okay, and the capital R x, which is the bigger radius, as you can see that no matter how you move your washer, the larger radius is always 2, right? The larger radius, which is 2 constant. So the area of the cross section, which is pi r squared minus pi small square, which gives us is pi times 2 squared minus pi times x over 4 squared. Turns out this is pi 4 minus x squared over 16. Okay, x squared over 16. And then we can put this back to here, which is pi times 4 minus x squared over 16. And up to here, we already formulate the integral for the volume of this revolving solid using the washer method. Okay? And you can evaluate this integral. It turns out that the solution of this integral is also 128 pi over 3. So I'll skip the calculation for this integral because those two are the same. So I hope this can give you another idea about how to construct the shell method and the washer method. Okay, and then also the difference. Okay, so I'll stop here, and I hope you enjoying this video.